Welcome to the course Business Analytics and Data Mining Modeling using R. So we are going to start our discussion on next topic, that is dimension reduction techniques. So let's start. So first let's understand the context. So generally whatever discussion we have done till now, we have been talking about the different variables predictors that we generally require to build a model. So sometimes if there are too many variables, because we are also dealing with a large data set, when we talk about data mining modeling, we are generally dealing with large data sets. So sometimes there could be too many variables, and subset of some of these variables might be highly correlated. So we are of course looking for some amount of correlation, so that some link or association can be established, which could be used for prediction. But if the correlation is on the higher side, then the information overlap could be problematic, because few variables, if they are highly correlated, they can lead to spurious relationships, because they are going to dominate the model. So their coefficient, for example, if we are running regression, if we are doing regression analysis, then they will dominate, their coefficient will dominate, and the other variables coefficient might come down. So therefore they will dominate the influence on the outcome variable, that is y. So we don't want that. We don't want our model to be spurious or results to be relationships or results to be meaningless. So we want to get rid of this this highly correlated variable problem. So dimension reduction techniques are actually used for this purpose. Then there are computational issues as well. For example, if we are dealing with too many variables, sometimes computation might take more time, especially if you are running different variants of your techniques, and so many candidate models are there. So it might be time consume, too much of time would be required to do your modeling exercise. So for that also we would like to reduce the number of variables. Now another region could be cost of data preparation, exploration and conditioning. So we talked about this phase and the kind of things that we are required to do in the data preparation, exploration and conditioning. So that might take more time if there are more number of variables, right? For example, visual techniques that we covered, right, that might require more time, and so the cost of modeling would go up. So that could be another region. So dimensionality. So we talked about in previous lectures, we talked about principle of parsimony, where we said that we want a variable to have as few variables as possible and still be able to explain most of the variation in the outcome variable. So that is the desirable property. So therefore we would ideally look to reduce the dimensionality of a model, right. So therefore large number of variables, we always look to reduce the number of variables, but we want to retain the important variables in the model. So we need to identify them, and some of the problems, for example, some variables being highly correlated, we want to get rid of that also. Dimension reduction is also called factor selection or feature selection in feature extraction in some domains, especially machine learning, artificial intelligence. So there some other names are also being used. So what are the different dimension reduction techniques that can be used? So these are the few that we are going to cover: domain knowledge, data exploration techniques, data conversion techniques, automated reduction techniques, and data mining techniques. So domain knowledge is the one that we generally that can be very handy if you understand the phenomena, if you understand the underlying theories that are explaining that particular phenomena, you understand the key variables construct, and keeping in mind the kind of task that you have to perform, you can easily identify key variables, because you have been working on that area. So because of the knowledge that you have about the phenomena, about the variables construct and everything else, that can help you, that can put you in a better position in identifying key variables. So so in that fashion you can reduce the dimension. You might not use other variables data in your modeling, and that is going to help. Removing redundant variables, some variables through that same process, if you understand your area, you will immediately understand that these variables are not useful, so you can get rid of those variables. Sometimes if you have been involved in data preparation exercise and the collection exercise, you would also know some of the variables which might be having erroneous values because of the way the data might have been collected. It might not, those variables might not be suitable because some errors will come into your model, and the results that you actually might expect might not come, and your own arguments and theories might not be justified. So therefore, we can also identify these erroneous variables, and if we can handle them, we should go for that. Otherwise, we can get rid of these variables as well. Measurement issues for variables. So sometimes we also have to see, if a variable, if there is we need to repeat the exercise, can the variable be measured again? Is it easy to measure that particular variable? So those kind of things also. So that is from the project point of view. If you are running a project for your business organization, and there is some business goals and the relevant business analytics exercise that you have to perform. So you will also have to see whether a particular variable can be again, it can be data on that variable can again be measured and collected. So that is also you have to see whether the exercise can be repeated or not, right. So those kind of issues could also be there. Next is data exploration techniques. So some of these things we have already discussed in previous lectures. For example, descriptive statistics, that can also help us in reducing the dimension. For example, summary statistics, sometimes we might be easily able to see from the summary itself, we can identify important variables, and we can also identify the variables which we can get rid of. Pivot tables in Excel, that can also be used to again look at the summary level data and make further decisions about your modeling exercise. Correlation analysis can also help you identifying the variables which are correlated and should be included in the model. Highly correlated variable can also be identified there. That can again help you in determining which variable you need to have closure. You have to perform closure inspection, and so that is also, so correlation analysis is also going to be quite helpful in reducing the dimension. Then we have visualization techniques that we have covered in previous lectures. So let's go through some exercises for these techniques. So let's open our studio. Let's load this particular library that we have been using in every exercise. So used cars data set, this is the one that we are going to use for this exercise. Let's import this data set again. Now first 10 observation, we have already seen this data in previous lecture, but let's have a look again. So these are the variables. You can see, you are by now you should be familiar with this particular data set: brand, model, manufacturing year, fuel type, showroom price, kilometer price, transmission, owners, airbag, and C price. So these are the variables. Now another variable of interest that we have been using in other lectures as well is age. So we are going to compute age like we did in previous lectures from manufacturing year. Let's append this to our data frame. Let's take a backup, and first three variables we were not interested, so let's drop them. And now let's have a look at the structure. So these are the variables of interest, right? 9 variables, you can see, one being the categorical, others being numerical. Now let's look at the summary statistics. Now this is one function that is also part of summary statistics that we are going to create. Count blank. So this is going to count the number of blank cells that are there in a particular variable, in a particular column, so that we can identify if there are any missing values that are represented through blanks, right. So if they are represented through NA or some other format, So we can use that and create our write our own function and find out if there are any such values. So let's create this function. So you can see a function has been created, count blank function has been created. Now this is the data frame that we are going to create, that is based on summary statistics that we are going to compute. So mean is 1, then we are going to compute median. You would see that first column we have eliminated because this being fuel type being categorical. So there is summary statistics are mainly applicable to numerical variables. Mean, median, then a minimum value and the maximum value. So that will tell us the range, then the standard deviation, right, then the length for that particular column, how many observations are there, then the count blank also, so that we can easily spot right, which variables are having all the values and if there are any missing values at all. So let's execute this line and find out more about these variables. Let's look at the results. Now you can see all these variables are having 79 as count, so therefore 79 observations are there, and no variable is having any missing values. Count blank numbers are 0 for each variable. So we are on the safer side on these two counts. Now let's look at the range, minimum and maximum value. You can see the range for different variables, SR price and price, kilometers, so different range you can see. You can also look at the median values and the mean values. So these values can also help you understand, average values are going to give you the their central sense of data, centralized numbers of the data. A minimum and maximum value will give you the range of the data. If the you can also compare average and median value. So if the average is higher than the median value, then probably the data is right skewed. If the its average mean value is less than the median value, then probably the data is left skewed. So that kind of thing can also be understood from these statistics. Now this brings us to our next part, that is pivot tables. So pivot tables can also be used, so we can there is some level of interactivity that can be achieved using Excel's pivot tables, and some kind of combining categories and understanding the relationship between variables can be understood using pivot tables. We will see how. So let's open the Excel file. So data, so you will have to select the data, and once you have selected all the data, so let's select all these variables and all the observation. You can go into the insert tab and there is pivot table there. You can create the pivot table. We have already created one for you. So this pivot table is there. If you look at the first pivot table, so once you create the pivot table, you would have this kind of a view, so where all the variables would be listed on this particular right top of your Excel file, and all the variables you can see. Now you would have report, filter, column label, row labels and values. So in this particular example, we have taken transmission variable in the row side, and in the values section we have taken the price, right, and for the price also it is the counting of those values that has been done, right. So if we look at this particular table, you would see transmission 0, 63 such cars are there, and for transmission 1, that is for automatic, 16 cars are there. If we look at the another pivot table, that is in more detail, you would see we have now two labeling. One for kilometer is on the row side and the transmission is on the column side. So transmission 0 and 1, and then different ranges have been created, right. Once you create a pivot table, you will have to group them. So you will have to group them to have this kind of result that we have. If you are in your own time, you can learn more about the pivot tables. So different binnings, so kilometers have been binned into these groups, and you can see the values for these bins across these two categories of transmission. And if you look at again the price, average of price values have been taken. So, the values that you see in these cells, these are actually the average price. You can see average of price value 5.8 and row is this 19 to 29. So, these kind of values they can easily have here. From there these kind of values you can easily spot if some of the categories can be combined, right. For example, if km was a variable which we wanted to convert into a categorical variable, therefore how binning can be done, and the kind of sizes of those bins and number of such bins, that those kind of decision can be performed. For example, if we look at the 79 to 89 range and 89 to 99 range, if we look at the average pricing for these two ranges, this is quite close. So, probably we could have clubbed these two bins. Similarly, if we look at 29 to 39 and we look at 39 to 49, the average pricing is quite close. So, therefore, we could have combine these two bins. So, this kind of combining can be done because as you know, when you have categorical variable and when you do your modeling, you will have to create dummy variables depending on the number of categories that are there in the variable. So, that would actually increase the dimensionality of your model, right, and you are always looking to reduce the dimensionality. If there are few categories, that is better for the model. So, we are always looking to reduce the number of categories for a variable. So, we are always looking to combine some of the categories or drop some of the categories if required. So, that kind of thing can be easily done using pivot tables. Now, next thing that we can do is correlation analysis. So, as we talked about, correlation analysis can be helpful in identifying the highly correlated variables. So, let us open RStudio and we will understand through an exercise. So, again you will see the same data frame, the used cars data set we are going to use. You would see the categorical variables we are not going to consider for correlation tables because the variables have to be numerical. So, core is the function. So, this is something that basic stat is something that we have covered in our supplementary lectures. So, you are advised to actually go through those videos, those lectures. So, correlation, let us compute between the variables. You would see SR price. So, this matrix you would see in the row and column we have the same names. All the numerical variables have been selected: SR price, KM price, owners, airbag and age, and you would see now this particular matrix is symmetrical. From the diagonal, all the diagonal values are 1 because the variable is going to be 100% correlated with itself. Therefore, all these values are 1. Now, we want to get rid of the upper triangular. So, this we can do through this particular function upper try. We will set it to NA and then later on we will get rid of this. Print is the function that can be used. So, we can leave NA as blank and we will have this particular correlation table, which is now showing just one half lower triangular matrix, and we can see the numbers. If we look at the numbers, you can see price and showroom price, they are very highly correlated, 96% correlation, 0.96 is the correlation coefficient here. Similarly, we can look at some other numbers, for example, airbag and SR price 43, and then we can have look at other numbers like age and KM 53. Similarly, airbag and price, they are 35. So, there are some highly correlated numbers, price and showroom being very highly correlated. So, these highly correlated numbers we can easily spot, and then we can try to understand if some of these variables can be some of the dimensionality can be reduced. But in this case, SR price is an important variable. It being correlated with the price is because of the that SR price is mainly determining the used price of a used car. So, because of that, this highly correlation is there. So, we do not need to get rid of because this being a key variable and important variable, and its relationship is again with the outcome variable of interest, that is price. Now, there is another function that can be used to perform the same thing, that is simnum. Simnum is one function that again displays the correlation table, you can see here, but the instead of the actual numbers they display the different symbols for different range. For example, any correlation value that is between 0 and 0.3, that is left blank. Then any value that is between 0.3 and 0.6, they would display it using dots. You would see 4 dots there. So 4 correlation values are dots. So this is easier for, because we are generally looking to identify the variables which are slightly on the higher side, so more than 0.3. So therefore you would see any value which is any correlation value which is more than 0.3, we are interested in knowing those two variables. So 0.3 and 0.6 are being depicted by dot. There are 4 such values. Then 0.6 to 0.8, they can be depicted by comma, we do not have any such value. Then 0.8 to 0.9 by plus, then 0.9 to 0.95, that is by asterisk. So we do not have any such value, but 0.95 to 1, that is depicted by B. So that we have one value in this category, that is price and showroom price. So immediately we can spot through these symbols, right. So because we are interested in identifying the highly correlated values, so this can actually help. So this is another function. So let's go back to slides. Now another method for reducing dimension could be data conversion techniques. So if we have a categorical variable and many categories are there, and we can have a look at the data and identify the categories which can be combined. So combining categories, as we discussed, that can reduce dimensions. Similarly, if we have a categorical variable and it is possible to convert it into a numerical variable, so that can also help us in reducing the dimension. For example, suppose we have collected data, so on age groups, so we have not been able to collect the data on actual age of a individual, rather we have age group information, so particular record belonging to a particular age group. So in that case, depending on the number of age groups that we have, so those many dummy variables will have to be created for our modeling exercise, and that will increase the dimension. So we can reduce this scenario, because age essentially is a continuous variable. So we can, if there are many more categories, right, if there are many more categories for age groups, we can treat it as a numerical variable. So the middle value of a particular range can be assigned, that mid value of a particular range can be assigned as the value for that particular individual, age value for that particular individual, and we can convert this categorical variable into a numerical variable and thereby reducing the dimensions. So this can be done. Similarly, for categorical variable, as we talked about in the previous exercises as well, if for two groups, if there are similar kind of numbers are there with respect to our outcome variable, then probably we can combine them. If there is one group which is having very few number of observation for that group, we can also drop it, or we can combine it with the major category. So that kind of combining can be performed using data conversion techniques. So let's open R Studio and let's do the same thing through an exercise. So in this particular case, again same data set we are going to use. So age is the variable that we have in our data set, age of used cars. So let's convert it into age groups. So df age, this was numerical variable, we need to use the as dot factor function to convert it into a factor variable or categorical variable. And now we are trying to extract the labels, so of this particular categorical variable once created. So you would see age groups has been created and different labels can be seen here in the environment or data section, 2, 3, 4, 5 and many others. Now for further coding, we would also require these groups in numeric format. So we are trying to create another variable to store the same information. Then we want to create a bar plot which we'll see later on. So for that we need to create this C price, that categorical pricing that we had created for this particular data set by age, right. So let's do that. So there are two groups for categorical price, one is 0 and one is for 1. So used cars with less than 4 lakh value, and then used cars is greater than or equal to 4 lakh value. So these two groups we have, one is, so two variables we need to create for each of these two variables, right. and for different age categories, right, we are trying to find out the these values, we are trying to sum them up. So you would see first C price age 1 is actually we are trying to find out the percentage values where age is a particular belongs to a particular age is there, and it belongs to a particular age group, and the C price is also 0. So we want to find out the percentage of that. Similarly for C price 1, we are going to perform the same thing. So let us run this. You would see that different two different variables, C price by age 1 and C price by age 2 have been created, right. So 9 groups were there, you would see 9 groups were there, and 9 values have been computed. Now let us create a matrix of these two variables. Once this is done, this particular information, this particular variable can be used to draw a bar plot. The x-axis is again going to be categorical as we have been doing before. So age groups, the labels from the age groups would be taken for this labeling, right. Limits have been specified appropriately because this is going to be percentage number. So 0 to 100 is the range for y limit, and then because there are 9 groups, so this they are going to be captured in this range for x axis. So let us execute this. You would see that a bar plot has been generated. Now you can see that 0 is represented by this higher intensity shade of gray color, and then 1 is represented by a light gray color. So you can see for age group 2, 3 and 4, you would see that proportion of these values, this is number of cars for these is same, right, and count of these cars for other groups, this is slightly different. If you look at these 2, 3 and 4, if from here if we can see that probably age group 2, 3 and 4 they can be combined together, right, and similarly age group 9 and 10 they can also be combined. If we look at age groups 5, 6 they can be combined. Similarly age group 7 and 8 can also be combined. That is mainly because the proportion does not change. So therefore we can combine these categories. So effectively we can reduce the number of categories from right now they are 9 to 1, 2, 3 and 4. So we can reduce from 9 categories to 4 categories, so thereby reducing the dimension by 5. So this kind of combining categories can always be done as we talked about. Now let us do one more exercise for time series data. So this hypothetical data we are going to create, this is time series data. So this is sales for sports equipment sales in rupees crores for each quarter between 2012 to 2015, and for each quarter these numbers are given. Let us create this variable sales, and a time series is being created for the same. You can see the frequency is 4 because this is quarterly data, and the sales data is being used from 2012 onwards to 2015, and this time series has been created. Now let us plot this. Now let us have a look at this particular plot. Now you would see that, let us look at the 2012 data. So there are going to be 3 points as we saw in the data itself. One second point somewhere here, and third point here, and the fourth point. So it is always at the fourth point where some peak is happening. So it is in the fourth quarter where there is huge spike in sales. But if we look at the first and second and third quarter, the numbers are quite close to each other. So we are looking to combine categories. So we are looking at if we have sales data for different quarters, and we are interested in analyzing the same quarter wise performance. So probably we can combine the data for quarter 1, quarter 2 and quarter 3, because the kind of numbers that we have for this time series, you would see that the performance is quite similar. So we can group them into one, and the peak one could be the another group. So this is how combining can be done even for time series data. So we will stop here, and in the next lecture we will start our discussion on automated reduction techniques, and the one that we are going to cover in this particular course is principal component analysis. So we will start from there. Thank you.